actually gonna go here first. Let's see what we have. Oh, here comes something.
Everything. One.
Oh.
There goes him. You have to shrink it.
That's what I don't understand. Why do I have to shrink some things?
It's Wendy.
Yes.
Hey, could you finish our sauce for just a minute, please?
Yes.
Thank you.
Why does everybody go to the office? I just said that. There's more little buttons.
Okay, let me stick this outside. Actually, no. Let me give you a pop door.
They're trying to party.
I don't know. All right, let's start off with some multiplication here just to get us warmed up. Let's go with this right here. Okay. Use that as a reminder. Let me hang this up. Stuff. Let's just work through it. So 3 times 8, everybody.
24.
24. Put the 4, carry the 2. 3 times 5, 15. Plus 2 more would be 17. So your top row should be 174. We're done with that 3. The dinosaur puts his egg right there. And now we multiply with 4. 4 times 8. 32. 32. Put the 2 and carry the 3. 4 times 5, 20, plus 3 more is 23. So your second row should be 2,320, and then add those up. 2,494. Okay, should be what we get. If you didn't, see if you can look inside and find where you might have made a little bit of a wrong turn. The more we do this, though, the better we're getting, okay? All right, let's do one division problem just to, like I said, warm up. All right, 675 divided by 3. And go ahead and check it with multiplication when you get finished. right, so when we jump in here to work this, a lot of times we're having to grab that other digit, but can we get groups of 3 out of 6 this time? Yeah, how many? 2. So I would put my 2 right above that 6, and 3 times 2 is 6, and that's what we subtract and bring down. What do we do with that? We brought down the 7.
Get 2 3s out of 7.
Same thing, 2 3s out of 7. 3 times 2 again is 6, and subtract that. And we're ready to bring that down. How many 3s can we get out of 15? It's like a fact family, 5. So 3 times 5 is 15. And that works out for us today to not have a what?
Remainder.
No remainder today. Okay, nothing left to bring down. What now?
I said no remainder.
All right, so to check our work, 225 times 3. So that number right there is our dividend right there. Okay. All right. You guys are, not only are you holding this skill, holding onto it, you're getting better at it, and this is going to help you so much next year. You don't want to get to 5th grade and have to start going to the next step of long division and you can't remember where you should have been in 4th grade. So that's why we're trying to hold on to this. This is a big skill. Okay. All right. So on Friday, we started adding and subtracting fractions. The fractions that we worked with on Friday, they had something in common. Anybody remember what they always had that was the same? It's been a long time. It feels like forever since Friday. What do you think?
Denominator.
They had a common, what we call a common denominator, a denominator that was the same, and so that helped everything feel pretty easy. Okay? So some of our next lessons will be adding and subtracting fractions, but it's kind of like we throw in an extra step here or there. But every time we're trying to get to the common denominator so that we can get to that easy addition or subtraction. Okay? All right. Before we get started with our slides, let me grab this. Dust. Okay. Alright, so if you would set aside, I'm trying to think if we need our whiteboard right now. Right now, just set it aside. If that means push it to the side, that's fine. Okay, now I'm going to put one of these on your desk. Please don't open it yet. I'm going to tell you some specific things to pull out. We're not going to have that 10 minutes of playtime right now. If there's time at the end of class, we might can do that. Okay. Alright, just leave them in the bag for right now. I'm going to ask you to pull out some specific colors. Some people just left these all. Or was this might have been my. Yeah, this might have been my group that I didn't use all of them in. That's okay. There, hold on. Let me get the other ones that are already pulled apart. Throw that one in here. Throw that one in here. I'll grab my other crate.
Jayla has hers like that too. Jayla's got some like that too. Jayla's got some like that.
Okay, let me switch out just because these are, it's not a big deal to pull them apart, but just don't want y'all to have to worry about that. It's the same thing, these are just pulled apart like the ones we used the last time we had it back. Okay. everybody's got one, a bag. Didn't miss anybody. Okay. All right. So instead of just exploring with these right off the bat, what we're going to do is use them for some math. Okay. So what I want you to do is pull out. Hold on. Let me think. Look at the size pieces. Pull out the I can't remember which ones were. Pull out the orange pieces. Let's try that one first. Okay.
All of them?
Yeah, get as many of them out as you can. I'll give you a minute to do that. Yeah, you might have to shake it around just a little bit to find them all. Okay. I think these are either 5th or 6th. And then you'll know how many pieces there are once you do that.
They're 6.
Okay, that's what these are 6, so you should have 12 pieces total because there's two sets in your bag. If you don't have 12, there might be another 1 or 2, in your bag. Okay? Alright, once you have gotten them out, put your bag aside to the side. You can lay it on top of your whiteboard if your whiteboard is still on your desk. Alright, so I'm going to put a problem on the board and I want you to show it. Okay. So, here we go. Okay, don't let yourself get distracted. We're not making things. We're not building things. We're fixing to show a math problem. Okay, so right now you just have a pile of orange pieces. Okay. Alright, so these are 6. So let's show, hold on one second. Let's show, okay, let's show that on our desk. So you're going to have this fraction and then this one laying beside it. Okay. You have orange. Something like that. 4 6 plus 1 6. Right now we're keeping them separate so we can see the two fractions. Okay. All right, so 4 6 plus 1 6. All right. Okay, Jella, this is what we need in front of us. 4 6 plus 1 6. Not written, but these. These are 6. So put 4 of them. And put 1 of them. Okay. Already got this. Let's do it with these. Put 4 of them right here. Now, do they have to be perfectly lined up like that? No, they could be in a big jumble, but it still would be 4 6. Now, using your pieces, what's the answer? What's the answer? What is 4/6 plus 1/6?
5, 6.
5/6. Now, you probably didn't need those pieces to figure that out, especially after Friday. But this is giving us some practice right now with a manipulative. Okay, and I think it's going to help us even more in just a few minutes. All right, let's try another one. Let's try, let's do a little subtraction here. So let's have this many in front of you. Okay, subtraction is a little trickier when you're using manipulatives because everybody's trying to do it a little differently. So I need everybody to have 5/6 in front of you, not the numbers, the pieces. So you should have 5 of those in front of you. Okay. Now I want you to show you're taking away 2/6. And I can hear it. Shh. I can hear you sliding those pieces away from the 5/6. So you had 5/6, you slid away 2 of them. What do you have left? Everybody.
3, 6.
We have 3/6 left. Okay. So again, I think you could have done this without the manipulatives, but it does help sometimes to see it. It's kind of fun too to do it this way. Do something a little different. All right, so now I want you to leave your orange out. Okay, let's not. Let's, we got this whole bag of stuff, Miss Wendy. Let's use something different. Put the orange back. I'm going to ask you to get out. Let's get out green and blue. Let's do that. Let's get green and blue out. Put orange back. Get out green and blue. Get out all of them. So green should be 5ths. If my memory serves me correctly. If somebody would put one of those circles together and help us remember, that'll help us know how many circles for sure, or pieces for sure we're searching for. Okay, so you should have 10 green pieces, and then there are 2 blue pieces. Okay? If your bag is bothering you, if it's in your way and you want to set it right beside you on the floor, that's okay. In fact, that helps me a little bit because I can see your desk a little bit better. But, okay, and we talked about it. Sometimes that happens. Real quick, I'll check my stash. I have a little
Wait, hold on, let me break down.
few long pieces that have, I don't see a green. I think they'll be okay. Anybody have too many green pieces? Is what might be the situation is I've got some extra bags. It could be in one bag. So we're not gonna go looking for it right now. Okay. If she just has 9 pieces, sometimes our pieces accidentally get in another place. I'll try to. Okay. All right, Brandon. Looks like you're missing 1. You got your blues too. Okay. All right. So let's do this right here. Let's try. Well, let's just match today. So let's do 2/5 plus 2/5. Okay. So in front of you, I just want you to have 2/5 and 2/5. 2/5 and 2/5. Not written down with the green things. Okay. Find 2 of them. Those are 5ths. So get 2 of them. Just 2. That's 4. Just 2. Okay. So 2/5 plus 2/5. What is 2/5 plus 2/5? Ishmael, what is it? 4/5. How come every time we do this, the denominator number is not changing? The numerator is changing, but how come the denominator is not changing? Yeah.
The denominator is not changing because we're not subtracting or adding it.
Well, you don't, do you? Okay, that's kind of the rule. What do you want to add? Okay. The denominator's telling you what size piece you're working with. Our size piece hasn't changed, has it? Okay. It's the top number. It's the numerator. It's telling you how many that you have. Okay. All right. So let's try another. This time you may find that you need both colors. Okay. So what if we had this minus this? Okay. So show that, please. One whole minus 3/5. I mean, are we like even allowed to do that? Because now I've got like part of my math problem here is a fraction and part of my math problem here is a whole number. Am I allowed to do that? Or do we need to say right now, can't do that? Y'all are quiet. What do you think, Mason? You think you can do it? Well, I'm going to take this. I know that if I have a pizza at my house and it's cut into fifths, it's a whole pizza, right? Before we start eating it. But I guarantee part of it's going to get eaten at least. You know? So, all right. You have this showing on your desk. Would you now please take away wait a minute now. Some of you have I see what you did. Okay. Take away the 3/5 from the one whole. Okay. Take away the 3/5 from the one whole. What do you have left?
2/5.
But y'all are sitting there holding this. Yeah.
Yes, it's 2/5 because like you start off as one whole and then you take away 3/5 from the one whole.
And you take away that from the one whole. Okay. All right, but can you show that with this? Like if I add, okay, like take all your green pieces, and put them, just push them to the side. Take all your fifths and push them to the side. All right, so Mason has just told us, and I agree with him. Okay, look, give me your eyes for a second. We're taking away from this, actually. Okay? So let's do this with just the blue. Okay? Let's do this with just the blue. So let's take away, it doesn't really matter that I've written this in green, I suppose. But let's just use the blue. Okay? So would you show taking away the 3/5? You don't have any green pieces right now. We're just pushing them to the side like we don't even have them. Okay, lay them all down. All right, with your blue pieces, would you show this problem, this same problem? Okay. All right, so you've got your blue pieces. All right, now take away the 3/5. I'm not hearing that little swishy sound. Why? Are you able to do it like this? Are you? Not really, not what I'm asking you to do. But I want to ask you to do something. Would you put the green pieces in front of you and push the blue pieces to the side? Okay. All right, let's change this using only your green pieces, would you show me this problem? Alright, I see this on a lot of your desks. Okay? But I want to make this a little clearer because some of you, I actually saw you doing what I needed you to see. Some of you are doing it slightly different. So let's do this. I want you to put up to the side. You know how we put the blue pieces to the side? You know what I want you to put to the side now? 5 of your green pieces. So right now, all I want you to have in front of you that you're going to use are 5 green pieces. Okay? Everything else needs to be pushed away. Okay. With those 5 green pieces, would you show this right here? Okay. Alright, what did you just do with those 5 green pieces? Can you describe it to me so that I can know what you did? Valerie, what did you do first? You took all your 5 pieces and put them together to create what? A hole. Okay, guys, that is super, super, super important. It's a little thing. It seems like a little thing that you just did on your desk, but it's super important to what we're doing today. You just took 5 pieces and created one hole, right? And then, Alexandria, what did you do? You just slid 3/5 away from the other 2/5. So we know the answer here is 2/5. But this is what's tough. Can you take your hands off of those for a second and look up here? This is what's tough about this is when we don't have those little cute things in front of us anymore and we just have this gets hard for people to understand, Valerie, because this does not have the denominator that these do. And it's so much easier when all the denominators are the same. There's a quick and easy fix to that, though. And you just did it on your desk. I want to know that you can do it with just numbers. What do you think I'm trying to get out of you here?
All one hole is just 5. It's just a hole like 5/5.
That's exactly what I needed somebody to say. Today in your work, you're going to see problems that have one hole. Okay? And sometimes it's just going to be one hole sitting there by itself. Sometimes it's going to have a fraction piece with it, like a mixed number, but sometimes it's going to be just this. And you're sitting there going, what do I do with that thing to be able to subtract? You guys are smart and you already know that any number over itself is equal to 1. Cha-cha-cha. Stand up.
Yes.
Now, you please be careful. Don't knock your little green friends off onto the floor. Okay? Stand up and help us out here. This will help wake us up, too. All right. Come on, guys. All right. This is a repeat after me song.
This is repeat after me song.
Any number
Any number
over itself
over itself
is equal to 1.
cha-cha-cha.
Cha-cha-cha.
Cha-cha.
Okay, the cha-cha-cha is not together. It's still repeat. Cha-cha-cha.
Cha-cha-cha.
Okay, that's kind of weak. All right,
Okay.
let's do it one more time.
Caleb, you know.
It's a sleepy Monday morning. Let's wake up. Ready? Any number
Any number
over itself
over itself
is equal to 1.
is equal to 1.
Cha-cha-cha.
Cha-cha-cha.
Much better. Okay, have a seat.
Me and Mark.
All right. So, again, leave your pieces alone. Put your eyes up here. Pieces are down, guys. Just like Caleb said, I need to rename that right there. The nice thing about one whole is I can rename it anything I need it to be renamed. If I'm working with 6, like we were at first, I could have changed that to 6, 6. If we're working to 50ths, I can change it to 50 50ths. I can change it to whatever I need it to be to equal one whole. And then all I do is add the rest of the problem. And you see how much easier that just became? It's just a matter of renaming the 1 to a fraction. And we know what 1 can be. Okay? So this is kind of like our extra step today. This is our extra step. One of the forms of our extra steps. Let me say that. All right, let's try one more problem. Okay, one more with these little foamy pieces out here. All right, let me think about how many pieces you have. Let's show 7/5. No. Let's not. Hold on. Let's show 1 3/5 minus 4/5. Okay. So, with your green pieces, would you please make 1 3/5? That's where we need to start. Using only green pieces, we need 1 3/5. How do we make 1? Make it a solid circle. Make it a one whole circle. Put the 5/5 together. Make a circle. That's your 1. Now put 3/5 beside it. Just put it beside it to be easier to see. Okay. So you're basically going to have this, right? All right, so start there. You have 1 3/5. Now slide away from it 4/5. Slide away from that 4 of those pieces. Don't use your extra 2 pieces. Put those away. Slide away 4/5. Take 4 of these away. Doesn't matter which 4. Okay. What are you going to have left? Yeah. 4/5. Anybody agree with that? Is that what you had? 4/5? Okay. Okay. Now, again, put your pieces down and look up here. What if I did not have all of this and all I had was this? Okay. Can you push your pieces back to where you were at the beginning when you had 1 3/5? Push those pieces back together. You should have one whole green circle and then 3/5 beside it. Okay. How many fifths do you have total there? With the 1 3/5, how many fifths total is that? Yeah. So how many fifths is that altogether? Count them.
8.
Okay. Everybody should be looking at 8/5. All right. How can we do this math problem if we don't have these cute little green things and blue things in front of us? Yeah.
3 minus 4.
So you're saying just take this fraction piece and minus this fraction piece? Okay? That's actually not what we need to do. First of all, we're not going to be able to get 4 from 3. Okay?
You would like the mixed number into a improper fraction and then subtract.
Okay. This right here needs to change. Remember this? Remember that? We started off calling it Ma. And then I told you that Miss Terry told us we could add that D in there. I'm going to change this to a mixed number. Sorry. It is a mixed number. I'm going to change this to an improper fraction. 5 times 1, remember that? We multiply first. Plus 3 more. Well, 5 times 1 is 5. Plus 3 more is what? Huh? 8. 8/5. We keep that denominator. That D reminds us to keep the denominator. Didn't y'all just tell me you had 8/5 in front of you? See, those manipulatives are helping you see this. But we change this to an improper fraction, and then we add the rest of the problem. That just became super simple. What is 8/5 take away 5/5? What is 8/5 take away 4/5? 4/5. Which is the answer that one of you gave me just a few minutes ago. Okay? All right, I just wanted you to see some things that were happening with these manipulatives. So right now, if you would take them and put them back in the bag. Okay. Go ahead and seal the bag up. Try to squish the air out so it's not this big fluffy thing in your way. Okay. I am going to let you leave this in the corner of your desk for a little bit. You can put your whiteboard away. I'm pretty sure we're done with that. Actually, no, don't put it away. Put it in front of you because we're fixing to use it. Okay. Alright, let's put our bags down. Alright, so grab your marker and your whiteboard. If you want to set that bag beside you on the floor, if it's in your way on the desk, that's fine. Okay. Alright, so I want to ask you to write on your board something. How many halves are in a whole? Okay, write it on your board. How many halves are in one whole? How many halves does it take to make one whole? What would be the denominator if you had halves? Y'all know how to make one whole. Okay. How many halves are in one whole? Mason, how many? 2. Okay. Yes?
Hey, could you repeat the attendance for me, please? It's not going through on the list.
Yes, I'm sorry.
Okay, thank you.
Let's take a pause. I don't know why that's there. All right, let me ask you now this. How many eighths are in one whole? Write that on your board. How many eighths are in one whole? How many eighths, Ishmael, are in one whole? 8. 8 eighths. Okay. How many, all right, clear that off. How many thirds are in one whole? How many thirds are in one whole? Brandon, how many?
3.
Just 3. 3/3. Okay. How many ninths are in one whole? Everybody?
9 ninths.
9 ninths. One whole is different for every type of fraction that we have. All right, getting back to business here. All right, so if that's the case, let's work this problem together. Write this problem on your board. Minus 3/8. 1 whole minus 3/8. Write that on your board. Okay. What is going to be our very next step? We've got to get this into a form where it's easy to do. So what's our very next step here? Yeah.
Find out what's 1 whole.
What would be 1 whole? How do I know that? What do I need to look at to figure that out?
Your denominator.
Your denominator, which is what?
8/8.
8/8 is going to be 1 whole. So my next step under this would be to write 8/8 minus 3/8. It's like I'm going to rewrite the problem, but this time I'm going to change the name of 1 whole. So write that underneath. Write those problems. Now, this just became an easy problem to do. What's the answer, everybody? 5/8. Okay? All right. Go ahead and clear that off. All right, we don't have just a 1 this time. We have 1 1/5. What's our very next step this time? Stay with me, guys. What's the very next step this time? Yeah.
1 1/5. Put it in proper fraction.
Okay. Again, we're going to change the name of this right here. Because it has that 1 with it, we're going to change its name using MAD. If you want to write that beside it to help you, we're going to multiply, we're going to add, we're going to use the same denominator. So 5 times 1 is 5, plus 1 more is 6. And we're going to use fifths. So 6/5 minus 2/5. Okay? Yeah. Yep. All right. And so our new, or not our new answer, but our answer is 4/5. Okay. What if you had this problem, and this is going to happen on the problem set, I'm just going to give you a couple of these. What if you had this problem and then it added onto it, oh, and hey, show it on a number line. Okay. So we would draw a little number line. But how do I know what to put, like, what whole numbers to put on my number line? Okay, I need your eyes here because this is important. I can't just slap, 0 and 1 on there. I have to be careful about that because look at how big this number is right here. It's what? Bigger than 1. So I need to go to what number on my number line? Yeah. If I go to 2, I should be just fine. So I am going to put a 0. I'm going to put 1 in the middle. And I'm going to put 2 over here. My number line just has to be big enough to show what I've got to show. Okay. If my number here was 19 and 1/5, I would need my number line to go to, say, 20. I need it to be big enough to get to, to show what I've got. Okay. What's my denominator? 5, so I've got to have fifths. Cut that into 5 pieces there, and then cut it into 5 pieces here. Every time you have a whole number, you've got to cut it into 5 pieces. I need you to be drawing this number line. So let me stop for a second and let you add that number line. Make sure you've got 0 and 1 and 2. Okay. Because it needs to be large enough to show our largest number. Now it's easy. Once we have a number line that's big enough, it's easy to mark what we need to mark. Can you find 6/5 on there? Sure you can. Count to it. 1, 2, 3, 4, 5. 6/5 is right here. That's where I'm going to start. And I'm going to take away 2/5. So I'm going to show those jumps. I'm going to take away 1. I'm going to take away 2. And I'm going to draw that little arrow because that's just showing which direction I'm going. What 5th did I land on? It should be 4/5. Let's check and see. 1, 2, 3, 4. Yep. This is 4/5. This is 6/5. Okay. Y'all remember doing this on Friday? Showing the number line. Okay. We didn't do it with every problem. We're not going to do it with every problem today. We're going to do it just a couple times just so we know how to do it. Okay. Now, does anybody look at that and go, I don't know what you did, or I'm confused about something, or just have some kind of question that you could ask that would help us all? Okay. Silence, that either means we're too sleepy to ask the question, or we're good, we don't have any questions.
I don't know.
Okay. Let's just try one more problem. 1 3/8 minus 5/8. Okay. And I'm going to ask you to figure this out, and also, well, don't worry about a number line yet. We'll do that later. You've got to do something first before you can do the subtraction. Do something first so that 1 3/8. Okay, Isabella, get it written. Let's get going. Okay. What does my 1 3/8 change into? You've got to include that step. You've got to include that step.
11.
How did you get there?
I multiplied 8 times 1 and added 3.
Okay, 8 times 1 is the multiply. Add the 3, that's the adding, and then we use that same denominator. So this changes to 11/8 minus 5/8. Okay. Now, just copying it off the board is not showing me that we truly understand what to do. We need to make sure that you know what to do. Now, what is the final answer here? 11 minus 5.
6/8.
6/8. Let's add a number line to that. Our number line needs to show this right here, this problem. our math problem has a fraction that's greater than 1, you need a number line that's greater than 1. We have 8 for our denominator, so we need 8s here, and we need 8 pieces here. Where do we start our number line? Where do we draw a dot first? 11/8. I know that's 1 3/8. I'm going to jump back 5/8. And I'm double checking that I've landed on 6/8 because it should be our answer right there. All right. You won't have to do that number line every single time, but it is important we know how to do it. Okay. All right. Any questions about how we got any of this? What we've got to remember is to go from here to here. Okay? Some of us, I think we're forgetting that step. We've got to remember to do that. That makes our subtraction or our addition so much easier. Okay. All right, clear off your board. We're going to pull some problems from our problem set in just a minute. Let's go ahead and put our boards away.